If we had a rectangle that was 1 unit wide and 1 unit long, we would say that its area is 1 unit square because 1 times 1 equals 1. This rectangle is a square because every side length is the same. If we had a rectangle that was 1 unit wide and we didn't know how long it was, we could use a variable such as x to represent the unknown length. The shape clearly has a length, we just don't know what it is. To find the area of the shape, we would multiply its length by its width. Here, that is x times 1, which equals x. If we had a rectangle that was 1 unit wide and we didn't know how long it was, but it was a different length than our rectangle of length x, we could use another new variable, such as y, to represent the unknown length. Again, the shape clearly has a length, we just don't know what it is, but we know it is different than the length of the x rectangle. To find the area of the shape, we would multiply its length by its width. Here that is y times 1, which equals y. We could have many rectangles with different lengths from each other, and we would label each length with a different variable. We could call this rectangle B. We could call this rectangle little a. And we could call this rectangle capital A. Notice here that the A's are the same letter of the alphabet, but the rectangles are different lengths, so we need to remember that a variable that is a capital letter is not the same as a variable that is a small letter. If the rectangles had a length that was not equal to 1, we could describe them by multiplying the length times the width. This rectangle would be little a squared because its length and width are both a, and a times a gives a squared. This rectangle would be little b squared because its length and width are both b, and b times b gives b squared. This rectangle would be y squared because its length and width are both y. And y times y gives y squared. This rectangle would be x squared because its length and width are both x. And x times x gives x squared. This rectangle would be xy because its length is x and its width is y. And x times y is xy. We cannot go any further with this multiplication until we know what the actual value of x or y is. Notice that we could also call it yx. We could call it yx if we calculated the area by doing width times length instead of length times width. No matter which value comes first, the length or the width, we still will have the same area and the same shape. So you should be aware that when you see a term written with the same variables and exponent values, but they are simply in a different order, they represent the same value and can be grouped together. Another example of this would be a rectangle that has length of b and a width of capital A. We would call it B capital A, but we could also call it capital AB. This rectangle would be SR because it has a length of S and a width of R, and S times R gives us SR. This rectangle would be BY because it has a length of B and a width of Y, and B times Y gives us BY. Finally, this shape would be called x cubed because it has a length, width, and height that are each x. Multiplying x by x by x gives x to the exponent 3. As you know, we can also have negative values in math. For the sake of representing our shapes visually, the white side of each shape will be the negative value, and we will write a negative sign out front. Positive AB, negative AB. Positive BY, negative BY. Positive A squared, negative A squared. Look at the following shapes. We could describe what we have before us by saying we have x and y squared and 3 and y and x and capital AB and 2. Or we could group things together and simplify things. If we group shapes that were the same together, we could say we have (2x plus 2y plus y squared plus capital AB and 3 and 2. The process of grouping shapes or terms together is often called gathering like terms. Because we like to keep things orderly in math, we write our expressions with the highest degree of the terms first, and we go down in descending order. If terms have the same degree, then we go in alphabetical order. This means we would write y squared plus capital AB plus 2x plus 2y plus 5. Let's try another example. We could describe what we see before us by saying we have b plus b capital A plus y plus negative b plus capital AB plus b squared. Again, we can group terms together. Gathering like terms would give us b plus negative b plus b capital A plus capital AB plus y plus b squared. But notice that we have a positive and a negative value of b, and that the AB shape and the BA shape is really the same. To simplify, the B shapes completely cancel each other out to get 0. And the AB shape would be written as 2 capital AB. Thus we would have b squared plus 2 capital AB plus y. Let's complete one more example. If you were asked to gather like terms, what would be the answer? Remember that you are expected to simplify things completely when you are gathering like terms. So cancel out negative values with positive values. Negative 2 plus x cubed plus negative y plus yx plus a squared plus a plus negative y plus 1 plus by plus 2x plus yb or by plus 1 plus 2xy plus negative 5 plus xy minus y squared plus 4 capital A could be grouped this way. x to the 3 plus a squared minus y squared plus 4 capital A plus 2 small a plus 2by plus 2x plus 4xy minus y minus 5. Finally, remember that if you were told to simplify x minus x, it looks like this. This becomes x plus x. Which is equal to 2x. Of course, we do not always want to or need to write out the geometric representation of terms when we go to simplify them. However, using algebra tiles does help us to understand how we can properly group terms together. In conclusion, let's try one example where we don't use the tiles. Simplify 2x squared plus 3c minus 5x squared yz plus 13a plus 2a minus 3x squared minus 2n to the exponent 4 plus 4 minus 2c plus 2a plus 2wn minus 2nw plus 3x squared yz. If we gather like terms, we can keep track of which ones we have gathered by using the same symbol to group similar terms. 2x squared plus negative 3x squared gives negative x squared. (3c plus negative 2c gives 1c, or just c. Negative 5x squared yz plus 3x squared yz gives negative 2x squared yz. (13a plus 2a gives 15a. Two capital A has nothing to group with it, so it stays as 2 capital A. Negative 2n to the exponent 4 has nothing to group with it, so it stays as negative 2n to the exponent 4. Plus 4 has nothing to group with it, so it stays as plus 4. Positive 2wn plus negative 2nw are the same term, with just the w and n in a different order. So when you add them, you get 0.